everyone, I am Anjan and welcome to the 27th video tutorial of the Verilog course series. In this video, I will be explaining the coding part of the LED blink in FPGA. Actually, this is the part 2 of the LED blink in FPGA. There is a video on part 1 that is on pre-coding part in the StarScratch YouTube channel playlist. If you don't watch it, I recommend you to watch it and come to this video, and there will be watch this video to go on to the third part of this video. And let's move on to the coding part, that is on the tool. And here is my code of LED blink. This is so long and going. Okay, and I declared a module name that is LED underscore blink and given the inputs, that is clock, reset and LED. LED as my output. And if you observe, I given registers as there is 6 registers I given, that is count reg and count next of 4 bit, and state reg and state next of 1 bit, and LED reg and LED next as 1 bit. And if you wonder what are these, in the part 1 of the video I explained about the I will show it. Part 1 of this video I explained the state missions, that is power on and power off. These are the states, and in this code I am explaining the states in the form of present state and the next state, that is state reg and state next as state reg as the present state and state next as the future state. To store those values of this power on, whether it is this x0, z0 and s0, s1, these store these values, I am using state reg and state next as my values, and LED reg and LED next you will get understand while going to through the code. And these are the power on and off are the parameters, because I will be using these one in my case statement. You can also use 1 bit decimal 0 and 1 bit decimal 1 in the case statement here, but I use it on to get a better understanding while reading this code. And to go through into the code, I introduce 2 always blocks in it. One is present state logic, that is if you using the reset pin, you can use the present state. You can give the present state of the, I am here declaring the present state of the code, that is count reg, whether it is count reg or state reg or LED reg. I am giving the present state values from the future state. So I declared it as present state logic, this always block. For every passage of clock there will be a reset pin, and if for the reset I will be giving count reg, that is if it is resetted, all the count reg, state reg and LED reg will be equal to 0, else there will be the next state will be given to the present state. And coming to this always block, I will be declaring the next state logic, so that I will give this next state logic to the present state in this always block. In this always block I will be giving count next as this present. You can get bit confused here, but there is no worry, because this is given because in this always block I will be giving this is to declare, so that there won't be any errors meanwhile. Okay, in here in the case statement I use the state reg. For the state reg, this is on the present state of this logic, so here state reg will be given to state next. But here within the code, this is like default statement. If you want written this whole code, you should write this one. Writing this one won't matter, won't make any change within this code, but writing this one is a good behavior. And coming to this case statement, this is the main part of the code, that is for on condition. You can also take in 2:1 mux, we discussed that for the input for this condition we will be getting this output, for this condition we will be getting this output. In the similar case, the state reg, that is for this state reg, this is not an input here in this case, this is a register, but register means this is like storage. For this storage device, in the on condition begin, if count next equal to 10, that is for 10 power 7 seconds. If count next equal to 10, that is count equal to 10. And here I also mentioned 4 bit because x equal to 4 we got in the part 1 of the video. If you watch there, you can get an idea of it, how I mentioned that count is equal to 4 bit. So we will be getting combination of like 10 power something second, 10 power not 4 bit means 2 power 4, that equal to 32, right? 2 power 4 16, sorry, 16 combinations. For count next equal to 10, we will be getting state next equal to state next, that equal to here count next equal to 10. That means the for every clock, for every, like I will be showing here you saw in the part 1 there will be 3 clocks, and this is the parent clock, like say clock cycle, and this is the child. For every 3 of the clock pulses there will be a single clock, so that we will be getting change. So to show the change I am using if and else statements. If count equal to 10, that means after 10 clock pulses of the parent one there will be change to state equal to next equal to off, will go to off, it will jump to this here directly. And count next equal to 0, count will comes to the beginning, and LED will be comes to the off not 0 state. And else if it is in the in between of the clock pulses, then the count next will be incrementing by 1 bit, and state next will be on, this will be remains in this state totally, and LED next will be 1. And in the off condition it is just similar, like if count next equal to 10, then this state will be changing to this one on state, and count next will be 0 and LED next will be 1. Here LED next equal to 1 in if, and here it is in else, because you can represent 0 as off and 1 as on. It is in off state, it should jump to on, so LED will become 1, and here it is in on state and it should jump to off, so that LED will become 0, like that you can understand. And here in the else, the count next will be incrementing by 1, and state next will be off, it will remain in the same state, and LED next will be 0 only itself. And here I ended the case. And next it is the output logic. I am using data flow modeling, and here I taken LED as my output, and I am giving the present state as my output to the LED, and here I ended the module. If you watch, I will be scrolling this. Okay, and here I will be ending this part of this video, LED blink. And if you are willing, if you are want to explore more on Verilog questions, related questions, you can check the description box below to check on the Verilog questions. And if you like the video, do hit the like button below and share it to your friends, and subscribe to the Start Sketch YouTube channel.